Hello, everyone. This video is about project one, which is uh, about modeling how different word orders are realized and how models can be selected out of training. So what we're going to do in the project, as I've described in the Moodle description of the project, is we're going to take some English data and write an English grammar for it. And in this grammar, there will be entries for like subject, verb, object, or object, subject, verb, object transitives, and also object, verb, subject transitives, so that depending on what kind of data you're exposed to, some of these categories will be favored and some will be disfavored without having to make an assumption about what kind of a priori assumption about what the basic word order is in English. So essentially, we're going to acquire the word order um, in English. Okay, so um, um, to do this, what we do is we write a grammar, and in that grammar, we lay out our hypotheses, and the consequence of that for modeling is there's a theory of grammar that says there are certain ways of writing categories, and that's going to give you a modeling space. And then we take that modeling space and say, well, if this is the modeling space, how do I train it on different kinds of data to get some different kinds of models out of grammar? And then we do the model selection out of that training. So I'm going to show you this process. Let me share my screen with you. So I am in the course repository in project one. If you look at this repository, you're going to see a grammar file called en.gram. And you're going to, like if you do en.gram, this is a grammar file, and there are some supervision files. So for instance, you can see en supervision file for SVO. Before I went to go to the supervision file, if you look at the grammar, you see that, for instance, knows, the first one is essentially SVO, that John knows the book kind of know. The second one is called a distractor, although it's subject, verb, object. It doesn't mean no, but it means hit. So it's sort of like we're assuming that the child is saying, assuming that when somebody says no, he understands hit. That's called a distractor. And the third one for no is OVS, in the sense that if you take out the first NP, which corresponds to lambda y, it is the subject because it's the most S commanding argument. So this is essentially OVS. It takes the object first and then the subject. Whereas in this one, if you look carefully, this noun phrase is X, corresponding to X, and X here is the commanded argument, not commanding argument. So it's essentially an object. Okay, and if you look at intransitives, walks and arrives are essentially all S under NP. So we're assuming that basic English is SV, but we're leaving it to the data to figure out whether English is SVO or OVS. So this grammar essentially says English could be SVO or OVS, but it depends on data. And if you look at what kind of data will bias English towards one category over the other, let me show you the supervision file for SVO. So if you look at supervision files, essentially these are pairs of forms and meanings. So on the left, you have the form separated by a colon. On the right, you have the predicate argument structure. So John loves Mary in SVO English means John loves Mary, John being the subject, and Mary loves John, Mary is the subject. And if you look at, for instance, Mary knows John loves Mary, Mary does the knowing, as you can see here, and John does the loving. John loves Mary. Okay. So this is essentially SVO English. And if you look at the intransitives, John arrives is essentially subject is first. So essentially SV. Okay. And if you look at the supervision data carefully, this is the only data that's going to bias your grammar one way or the other towards SVO or OVS. And if you look at, there are no hidden assumptions here, just form and meaning. And then you try to figure out what kind of training will take your your grammar to bias certain kinds of categories over the others. So as I explained in another video, when you train these grammars, what happens is they begin to acquire parameters. Let me show you the grammar. First, you see no parameters here. So you'll see that after training, there will be some parameters here. And that's when you can figure out, well, this category is biased positively. The other is unbiased, debiased, like negatively. And distractor is essentially captured to be a distractor, not because I call it distractor, but the data says it's a distractor, because in the supervision data, there will be no cases where the verb knows will mean hit. So this will be disfavored by supervision data. Okay. Now the tool we're using is the bench. And the bench is essentially, if you do the help command, which is the question, you can see a whole bunch of commands. Every command is essentially a one-letter command. If it's a letter command, then it's about the processor, like analyze, get me the case functions, evaluate this expression, or look at this gram. For instance, if I do gen.gram, the end of gram is essentially this dot here. The dots are essentially symbols, and if there is more than one dot, they are separated by comma. So gen gram says, well, check my grammar and see if there are any errors in it, because only well-formed grammars can be trained. So that's an important thing. And these logs go into your repository. So I'm going to show you in project one where these logs are about the kinds of errors in the grammar. The one that is important to us is called T command. It takes 3 arguments, dot, dot, dot. The first dot, it means train this grammar. And the second one says, well, train it on this supervision data. And the third one says, in the supervision data, use these parameters. Okay. So what are these parameters? Let me show you some parameters. Again, if you want to run a operating system command when you're running the bench, you can use the O command for operating system command. So if you look at experiment file, I forgot the name of the file. Let me just see the names of the files. This is the experiment file. So the experiment files are, every line is essentially one experiment. The first 3, these numbers, first numbers 1, 2, 3, 4, 5, 6, these are training parameters. This says use this much memory, use that much cache, do that number of iterations over data, because this is actually gradient learning. And these are the learning parameters. This is learning rate, and this is learning rate, which is these I've already described in a previous video. This says, well, save this experiment in SVO and parse what all the internal files, internal things, and and run this function before you do the experiments. Essentially, this one, the first line says turn the normal form parsing on so that there are less number of analyses per item. The second one says get 7 gigabytes of memory, use that much cache, and 15 number of iterations, 1.2 as the learning rate and 1.0 as the learning rate. How frequent do you want to change the learning? Okay, and save it as SVO experiment. No normal form parse. Why? Because I'm turning off normal form parsing before I run the experiment. So these are essentially the files that you need. Now, one nice thing about doing all this over and over again, because you'll be creating lots of models, is the add command. It says basically add command means do these experiments over and over again. So the first argument is this is where the commands are, and this is where you save the log file. And if you look at a command, I created a file for this. These are essentially the bench commands written in one file. So you don't, instead of doing it online, you can do it offline, like the batch mode. All right. So pass command is just for commenting what follows. So it's just a comment file, and then there's the T command. Just like you can run it on online, you can do it in batch file. Train the grammar file. Train it on the supervision data for SVO, and the experimental data set number of parameters, a number of iterations is in this experiment file. And then do the same T file on the same grammar using OVS as real English. and let me show you the OVS file so that you can see that in OVS file, it's essentially a pseudo English where the word order for the transitive will be object, verb, subject. Okay, and use this experimental setup. So let me show you that file. It's supervision. So this is all the stuff that you have in a supervision file is assumed to be what is understood, what is heard, and what is understood by the child. So these are assumed to be grammatically well for understanding. It's like John loves Mary, and if you look at what that means now, it means Mary loves John, because if it's OVS, Mary is the subject, and John will be the object. Okay, so but there is no distinction in intransitive. John arrives is arrived John. Why? Because I'm still assuming English is subject verb in the intransitive. When you look at more complicated clauses like John loves Mary knows Mary. The reason why this is obvious is knows Mary is the main predicate. So Mary is doing the knowing. And what Mary knows is that John loves Mary. And look at what John loves Mary means in obvious English. Mary is the subject. Okay? So this would be the obvious English if the child were exposed to that kind of English. So in this kind of modeling, the grammar is really a place where you can hypothesize anything like a thought experiment and then try it on data to see what kind of possible grammars that are envisioned by the theory of grammar is biased by data. Okay, so if you look, and I've conveniently saved all of this in this TBC file. So all I have to do is run this entbc, and I want the experiments to go to, this will be like SVO OVS distractor experiment. This will be the name of the log so that I can see what I was trying to do. If you run the experiment, it says, okay, I'm doing the experiment. When I'm done, I'm going to save it here. Okay. And if you look at what is created, uh, a directory, you see this log file. Okay. It's the log file that I wanted the system to create in this experiment. So if you look at that log file, it's just a summary of what it's going to do. It says, I'm going to run 3 experiments, and these are the parameters, so that when you, for instance, says I'm going to do normal form parse for OVS, and it's going to do its number of iterations 8, learning rate is 1.0, and learning rate is 1.2, all the stuff that you defined in the experiment file. All right, so when you do that, it creates files in a temporary directory, not in order not to clutter up your directory. So all these internal files will be in here, var tmp bench directory. So if you want to see the contents of this directory, here is what's been created. It's just been run, and it's been it's created like log files and then grammar files. These are internal files. So the ones ending with source are essentially an internal representation of the grammar for the benefit of adding parameters. So if you take one of these, there's a command called z command. Basically, it says z and an argument means take this source from var_tmp bench, so you don't have to specify var_tmp bench. It knows that it's located there, and then make it an editable file so that I can see it. Okay, so let me see the directory again. Okay, and then run the z command on a certain file that it created. For instance, this is a grammar file. Let me just type it, svo nf parse. Let's say I'm going to look at the performance of this experiment with learning rate 0.5 and learning rate 1.2. A and C are just reminders for the model. I'm going to explain that next week. And this is the name of the source file. So if you do the Z command, it's going to say, I'm going to create a source file so that you can have a look. Now, it's named this. This is added so that there is no name overwrite in the file system. So if you look at this file, you're going to see something like a grammar, but something added to it. I typed in something wrong. Yeah, too many dots. Okay. Oops. Maybe these long names are killers. SVO, NF parse. Yeah, I forgot SRC. This is the name of the file. I missed the SRC script. I'm not doing this deliberately. I just the file names are too long just to remind what we've done in so many experiments. So if you look at this file, oops, again, wrong again. Let's see. What am I missing? Yeah, I got this the extension in the wrong places. This is the name of the file, I hope. This is the file name I am trying to type instead of doing copy and paste so that you can see it. Now, here is the file. Now, the left part is going to look very familiar. It's pretty much what you've typed in as grammar. Nothing is deleted because it's just that on the right, you're going to see parameter values. Okay. These are the changes to your, initially they are all one. They're not probabilities, they're just weights. So you can start with any weight you like. The system starts with just one. And some of these have been increased to 3 from 1. Some have been decreased because this is, after all, if you look at carefully, the second line here is actually, this one here is the distractor, and this one is the OVS intransitive. But the supervision file was SVO, so OVS has been disfavored by this model, and SVO has been favored by this model. What's the significance of this? When you take the trained grammar and rank your solutions, SVO's alternatives for no's will come out on top rather than OVS and other or the distractor. That's the whole point of modeling the grammar to the point of training from supervision data. Okay. So let me show you the results of I've already saved these results in here, so I can show you one result, for instance, SVO. Let me show you the same thing, and first, right? Um, and then, it's in the results directory. So this is where I saved it. Not in this session, but in the previous session, I did this experiment and saved it here. Let me look at the same file, which is SVO and NF-parse. If you look at the log file here, this is the grammar source. In other words, internally modified grammar. This is the log of the summary of the experiment, the experiment log. Okay. So let's look at this file. It gives you a summary of the experiment. And here's the summary. It first says what kind of system resources have been used, like CPUs and others, what kind of rules are used, which is not too much critical for us. But here's the critical thing. Here are your grammar entities on the left, their initial values in terms of parameters and their final values after training. And if you look, and the difference, if you look, the first no is essentially the SVO. The second one is the distractor, and the third one is OVS. So this system, your supervision data is favoring the SVO because it's about SVO English. Now, what you're going to do in the project is by having a closer look at this grammar, you're going to modify the hypotheses about like intransitives and try to make English as a VS language. So for that to work in the model, you need to write the VS entries in the grammar so that they can be trained against SV alternatives of English. And once you modify this, you're going to take something like supervision file of OVS. If you look at that supervision file, This supervision is for the cases where English is obvious in the transitive, but SV in the intransitive. For the project one, what you need to do is in the supervision file, you have to have VS transitives, intransitives, sorry, so that you can see whether the system say favors SV or VS, depending on the kind of data it's been exposed to. And that's the whole business of modeling. You have an idea in mind, you write a grammar for it in which you have all your hypotheses laid out in the grammar, and depending on supervision data, you want these categories to be favored and disfavored to the point that one comes out as top, sorry, as the grammar of the language you're studying. Okay, that's the whole point. So watch this video before you set up your experiments and run your experiments and take your files from VAR-TMP to bench and have a look at them. And then and we'll talk about this in class on Thursday. And all you have to do is do your experiments, look at the results. You don't have to run that many experiments. You can run more or less, but at least one. So you can change the experiment file as well. And you can change the bench command macro routine to add your experiments. And then just bundle it up into a zip file and just send it to me. That's the whole idea in project one. All right. So that's the idea, and I'll talk about more of this on Thursday, just to wrap project one up. And after the spring break, I'm going to talk about what kind of methods allow us to train grammars like that so that parameter update can be done. There is a good, well understood mathematics behind it. I'm going to talk about that in the last 2 weeks of the course. All right. Well, then this is it for today, and I'll see you next week.